Welcome all of you to the next video lecture on classical mechanics. সকলকে স্বাগত ক্লাসিক্যাল মেকানিক্সের আমাদের পরবর্তী টপিকে। এই ক্লাসিক্যাল মেকানিক্স যেটা ছিল we are studying DOF, that means degree of freedom. Those who are new to our channel Step Up Bengal are requested to visit the playlist and follow from especially lecture 2, 3, 4, 5, where extensive discussions about degree of freedom has been done, especially L3 lecture 3, 4 and 5, 3, 4 and 5. All of you are requested to follow those. In the last lecture we have discussed how to calculate degree of freedom in case of 3-particle system. All of you are requested to visit the previous videos, otherwise they cannot understand or proceed further, especially to the questions of CSIR net. So from our team, it is our special request to all of you to follow previous lectures where we have discussed 3-particle system, motion about an axis in details. These results will help you to solve the problems of CSIR. Today we are going to discuss some problems of CSIR net on this topic, degree of freedom. আজ আমরা CSIR নেটের ডিগ্রি অফ ফ্রিডম সংক্রান্ত কতগুলো প্রবলেম সলভ করব। সলভ করার আগে লাস্ট ডে we have discussed how motion about an axis occurs, and in that case DOF were clearly 1. So one particular thing is to be done, that is unconstrained motion. We can see here, all of you I think can see here, unconstrained motion. What is it? Unconstrained motion means free motion. We all know unconstrained means free. So when a particle is free, so its degree of freedom clearly will be 3. For a single particle in R3, degree of freedom is clearly 3. So for a single particle, 3 scalar equations of motion would have to be applied, and finally we integrate those to obtain the equation of motion. All these we see later, but for this particular video, this result is very important result from classical mechanics book. All of you should carefully look about it, that when a particle is free of constraint, then it has 3 degrees of freedom, specifically in R3. When there is nothing specific is mentioned, so we can imagine it as R3 to specify its motion position. 3 scalar equations of motion would have to be applied. So one thing is clear, for a single particle 3 equations, unconstrained. Obviously unconstrained means free, there is no constraint. What is constraints and how they affect a motion or of a particle, those concepts has been extensively discussed in these lectures. You should follow those. So for one particle there are 3 equations of motion. EOM, in abbreviation we call it EOM. একে আমরা ইকুয়েশন অফ মোশন বলি সংক্ষেপে। তাহলে একটার জন্য যদি এরকম হয়, ফর n particle that will be clearly 3n equations, free particle for free, that means unconstrained and free are similar. Now what we have done so far, 3-particle system, that means rigid body, and we all know for rigid body DOF 3-particle system. This was three particle system. So in R3, three constants are there, three rods. We can see three rods. মনে রাখতে হবে যতগুলো রড ততগুলো কনস্ট্যান্ট এখানে ব্যবহার হবে. This was first particle, second and third. So total 3 into 3 coordinate x1 into x1 comma y1 comma z1. So 3 into 3 9 minus 3 equal to 6 constants are there. So rigid body is very similar to three particle system, and for three particle system DOF was one particle system. That sorry, motion about an axis of a rigid body. We have already discussed the motion of swing in for children in park. That motion is motion about an axis. So their DOF was 1. Now we gather all these informations to solve the interesting problems for CSIR net. Let us see one by one. This is the first problem. The problem came in CSIR net math December 2011 SCQ questions. If you have to do well in classical mechanics in CSIR net math, then we have to go to the concepts of CSIR net physics of classical mechanics syllabus. If we go through that syllabus and solve all the problems from physics background, then it becomes much easier to us to solve all the problems in the exam CSIR net math. So all of you should carefully look about it. The first option is, this is single choice question, that means one option is only correct. The number of degrees of freedom of a two particle, so two particle system is given. Two particle connected by a light rod of length L. Those are connected by a light rod. একটা light rod দিয়ে ওদেরকে আটকানো আছে এভাবে. In a vertical plane, so everything is happening in a plane. So in a plane we know that it is 2D system. Whenever we consider the motion of any body, a rod like system, then it is in 2D system. So in 2D system, vertical plane, this point is important. Each terminology is very much important to solve all the problems. Where one of the particles is constrained to move horizontally. So in 2D two particle system, if those two are free, যদি ওরা free থাকতো তাহলে 2 গুণ 2 2 into 2 4, that would be the answer. But some constraints are there, so we have to eliminate those constraints. Let us see what are those constraints. First look at that. In the vertical plane, the rod length is between A and B, so clearly one constraint to be eliminated. And they have given another constraint that is given here. We must carefully look about the fact that constraints are basically two types. One that is the connecting rod or something which joins two particle or n particles say. The other one is the movement. If we fix the movement but in a particular direction, then that movement is also one type of constraint. So what they have given to us, constraint to move horizontally, but this rod can only move horizontally. Say this is horizontal direction, so this cannot move vertically. Here it is given one of the particle is constant, so A should move horizontally, so that is one of the constraints. So two constraints clearly, দুটো constant, rod L, rod of length L, and the horizontal movement. So the answer will be 4 minus 2, that is 2. But is it given to be 2? Yes, this is 2. It is clearly given to be 2. So this is the answer obviously, because this is single choice question. Now let us see why the remaining are false. If you have seen all the previous video lectures, then you can easily in fact answer the question without depending on our discussion. যদি তোমরা আগে পড়ে থাকো easily পেরে যাবে সবাই, nothing difficult. The number of degrees of freedom of a door swinging on hinges is 3. We have already discussed door of a railway carriage. যে একটা রেলের ক্যারেজে কিভাবে মুভমেন্টটা হয়, দ্যাট ইজ মোশন অ্যাবাউট অ্যান অ্যাক্সিস অ্যান্ড দেয়ার DOF is 1, so it is here given to be 3. So this option is clearly eliminated. This is obviously the answer because single choice question. We have already the answer, but we have to go to all the concepts so that in future it will help you tremendously. Then now come to the next option. The number of independent generalized coordinates. Generalized coordinates. This is something new to you. We will discuss in our next lecture that DOF, degrees of freedom, which was in general of 3n minus k type, where k were constants and n was the number of particles. This is the degree of freedom. Say n, that means number of particles are 3. So the DOF in R3, obviously in R3, 3 into 3 minus, say there are 1 constant. So 3 into 3, 9 minus 1 equal to 8. So these 8, say x1, x2, dot dot dot, x9 are the free coordinates. And among them, x8 is a fixed quantity. So ultimately it goes to number 8. This is, then the coordinates becomes x1, x2, dot dot dot, x7. Then we don't have x8, so we must have x9. So there are total 8 coordinates. These coordinates are called generalized coordinates. So generalized coordinates we will see in the next video lecture. What is the importance of generalized coordinates? Now we should only have the information that number of DOF equal to generalized coordinate. In the next video lecture we should discuss it in detail, that how the syllabus of CSIR is heavily dependent on generalized coordinate system. So here the number of generalized coordinate system equal to DOF. To specify the simple pendulum moving in a vertical plane is 2. I have told you many times that simple pendulum is very much important, and we all know that there the DOF is 1, but here it is given to be 2. So this option is also false. Those of you who are new to this platform, please visit for simple pendulum, or rather the motion of simple pendulum, where the DOF has been discussed in details. There you can get all the information about simple pendulum, or rather the DOF of simple pendulum. But it was 1. So here it is given to be 2. So this option is also false. Then comes the next question. The number of scalar equations needed to determine the motion of an unconstrained n particle system is n. We have just seen that unconstrained n particle, for one particle 3 scalar equations are needed. So for n particle 3n equations will be needed. But here it is given to be n only. So this option is also eliminated by that previous result. So each of you should make a note of your own about all these important errors. Then you can easily solve the problems. So if you what we have seen, if we know all the results, then this particular question will take, say, 20 seconds. We can solve it within 20 seconds. That will help you tremendously. Now come to the next question. It came in CSIR Net Math, June 2011. What is the question saying? Now we see one by one. If this is also SCQ, single choice question, so one option only is correct. 3-mark question, as you know, in CSIR Net Math. Each question, this is from Unit 3. Unit 3 is heavily based on applied maths, and here you can see questions from classical mechanics. A free particle in R3 can have infinite degrees of freedom. This is obviously wrong, because in R3 the DOF will be 3n for a free particle, single particle in R3. A free particle means for n particles we have 3n DOF. for n particle we have 3, this is the formula, and free, so there is no constant. But here it is given that a single particle, a free particle in R3, a free particle, that means single particle, একটাই particle এর কথা বলা আছে, so clearly the DOF will be 3, that is finite. 3, that is finite. So how can it be infinite? So this is false. The number of degrees of freedom of n particles is greater than 3n. It is true if we consider R4, then what will be the DOF? The formula is obviously there, if there are n particles and for a single particle in R4 we have 4 DOF, so 4n will be the answer, which is obviously greater than 3n. But if we consider R3 or R2, then can it be greater than 3n? Obviously no, because in R3 we know 3n is the result, but they have given to be as 3n, greater than 3n, so this option is also false. Next, come to the next option. The number of n particle with k constant has 3n plus k. Here the problem is in this plus sign, because the result is 3n minus k. We have already seen in our previous lectures. So this is obviously false. So what is the true answer? This is the true answer. In a single choice mode exam, when the questions, some of the questions are in single choice mode, it is better to eliminate options than to make it correct. Because to make something correct is difficult. That is the matter of research often. But to eliminate options are often easy. So if we know all the results, then we can easily eliminate these three, and obviously this will be the answer. Let us see why. A system consisting of 3-point masses, so they are talking about 3 particle system. 3 rigid massless rods has 6 degrees of freedom. We have discussed today also, and as in before, that for 3 particle system the DOF is 6. But as we have eliminated 3 options, so obviously 4 will be correct, and it is result also. So DOF will be 6, and it is given to be 6. So this is correct. So again, very easy question. Now come to the last question of today's lecture. Consider two weightless, this question also SCQ, came in CSIR Net Math December 2015. Consider two weightless inextensible rods AB and BC suspended at AB and BC rod suspended at A, so A থেকে ঝুলছে, and AB, first of all we should draw AB, and finally BC. This is the system, and since it is hanging in 3D space, so we have to be in our mind 3n minus k formula. This is the formula. Joined by a flexible rod joined at B, those two flexible rods, two weightless, two rods, so two constants are obviously there, and there we have suspended at B. Then the degrees of freedom of the system, they have spoken about the degrees of freedom of the system. Now look at the beautiful result here. What is happening here, and why we have degrees of freedom in case of such system will not at all be easy, because it can only be done with perfect conception of the topic DOF. Here we have two weightless inextensible rods suspended at A, joined by a flexible joint at B. So this point is fixed. We have in general 3 particle system. One particle is here, this is second is here, and the third is here. Now instead of solving this particular problem totally, I am giving you some clues, because by giving these clues you can easily verify and easily solve this problem. From next video lecture, first of all we should like to solve this particular problem in details and then go to the next video. So don't mind that it is not going to be solved, but first of all you should think of your own to solve it. I am giving some important clues, and by that clues and by previous lectures you can easily solve it. A is fixed, so three particle system, total 3 into, if these three are free, then total 3 into 3 9. But this point is fixed, that means already 3 is eliminated. 2 constant, 2 light rods, so these two is also, these two are also eliminated. So ultimately 9 minus 5, so 4. The DOF should be 4. Here the DOF should be 4. And if we analyze this problem clearly, is it given in the option? Yes, 4. But as I requested you, you should think of yourself in details why 9 minus 3 minus 2 I have written. And for that you have to go through three particle system discussion of previous lectures and solve it in details. In case of any difficulty, I will help you, but obviously the answer will be 4 here. So for today's lecture we should stop here because it is getting lengthy. And from the next lecture, as I have told you already, DOF equal to generalized coordinates. We would see in details how the concepts of generalized coordinates came into classical mechanics, who was responsible for it, and etc. So until then, goodbye. Hopefully all of you have understood today's discussion, and in case if you feel interested in these topics and feel that it will help you in the upcoming exam, especially in CSIR net June 2023 version, then please like, comment and share this video so that all of you might take the advantage of these lectures. So from the our team of Step Up Bengal, it is goodbye.